Hello, welcome to Day 6. Today we will talk about how to integrate an AI agent to our modernized dotnet 9 CRM product. All topics are: first, build an MCP server that consumes that backend API, build a MCP client and a chat client to serve it as a REST API, and develop a chat page inside the React Next.js interface. This is overall MCP architecture that I will follow. Let's divide this into pieces, and one by one we talk about our strategy. Let's remember, right now in the end of the 5th day, we already completed the REST API, as you can see here, and the React UI that consumes that REST API. Even with .NET backend modernization combined with modern Next.js React UI, the user interaction capability is still limited. Think about it. With this user interface, we have the capability for create, read, update, delete actions easily and fast. But we can't get all the informations when necessary. Yes, there is a search capability, order by column functionality, but there is still something missing. For example, this category is listing, and editing sequence doesn't have the capability to show the most top categories according to top product count, or categories that have most or less ordered. Those are sounding like some reports. Maybe those can be developed as a reporting section. Can think about like this. In upcoming sessions, I will talk about how affordable, cheap, and efficient to develop an MCP server and client instead of reporting server along with reporting clients. We will build MCP server and tools, resources, and prompts inside it. Those will be a wrapper to REST API functions. Why building here tools over REST API instead of directly using an SQL MCP server directly to connect to the database? First, security purposes. We don't want to share all database structure, information, and data with agents. Second, the CRUD REST API is the API that we are using for the user interface, so the toolset for the users has been already decided at that point. An AI agent is here no more than a power user for this application here. Third thing is the logging and metrics are already defined in the REST API backend. Last but not least, the performance, of course. All the rate limiters, fraud layers, countermeasures, database separation strategies are defined at the REST API gateway. All of those and more reasons building the MCP server over on top of REST API gateway is an elegant choice. Let's create a web project inside source folder. This will be our MCP server. We will add a model, context protocol, nugget packages to the project. Let's edit the program CS for the MCP server web project. Add some logging, same as the backend API has, same there. Then after, add a singleton generic HTTP client that has the CRUD backend API URL as a base address. This HTTP client will be used to send and retrieve data between backend API and MCP server. Finally, we can add an MCP server with HTTP transport and map the MCP tools and run the app. Here I try to wrap around my gateway API with MCP tools. Here, as you can see, I'm trying to abstract the implementation as much as I could. For example, get all method of team name to be used for generic types of my entities open from API like categories, customers, suppliers, orders, products. Basically, we can call the get method with HTTP client. We use the relative URL of the entity at the API. API will return the elements in JSON format, and here it will be parsed. Same way, we could also implement the get paged method. The URL pattern is known, and again with HTTP client we call the get method, collect the JSON response, parse and return the same type. Here we are returning the page list of T. T is generic, but page list is our creation, as we remember from the day 1 API. The page list and all other DTO model files must be linked to the MCP server. This way, MCP server also know the types of the gateway API. As you can see, the external filings are here. Let's go back to generic tool helpers. Same way we can implement in the get method of single entity with an ID. Here also you can see the IDT is generic type of the entity key. This way we can handle the integer, string, combined keys from generic methods. A generic save wrapped over HTTP method of our API, as you can see. A generic delete wrapped over HTTP delete method of our API. Since the tool helper methods according to our gateway API are ready, we can now develop the actual tools for AI agent inside our MCP server. Let's start with category. First, we create a static class called category tool with MCP server tool type attribute. This attribute in the assembly will indicate this static class is a toolset. For further usage, I will define the entity name and its plural as constants. Here, I will use those create generic descriptions. That makes easy to create copies of descriptions across tools now. Since the helper methods are created, we can easily create a getAll method for categories. What is important here is the MCP server tool attribute and its description. AI agent will look upon to this attribute and understand the functionality from its description. Same way we can easily create a getPage method for categories. Return types are ORDTOs, as you can see. Same way we can easily create other methods like getById, save, and delete for categories. Let's put in the launch settings an HTTP profile that will run the MCP server at the port 5207. We can move on testing now. The server is ready. First, start the API at the port 5205, like this. Optionally, we can start also the React UI at the port 5206, like this. We can start the MCP server at the port 5207 with npx at model context protocol /inspector command. At the PowerShell, we can start the MCP inspector. The MCP inspector is a developer tool for testing and debugging MCP servers. It's open source and can be found at the GitHub. For the MCP inspector, use the URL of MCP server with SSE, server sent events, transport type, and URL localhost with port 5207/SSE. This will be the MCP server endpoint. If we click the list tools, we can see all the tools that we have implemented at the server. For example, if we click the get all categories and run tool, we can observe the MCP server make an API call to the categories and retrieve all the categories data. This way we can test our MCP server and may write test cases for unit testing. All the MCP tool responses needs to match the API gateway responses. We came so far to MCP server. Next step, we will implement an agent REST API. There will be two components inside this API, an agent and an MCP client. MCP client is consumer of the MCP server and make calls to the tools. Agents integration will integrate OpenAI model or any other agent-capable LLMs. This component manage the communication between AI and MCP tools. Finally, the React user interface will consume this REST API along with the CRUD REST API gateway. Basically, React UI posts a prompt query to the agent REST API, and this API will generate response asking it to the OpenAI models. The model will use the data from the MCP server tools and generate a response. Let's start a .NET web project to be able to make a web API solution. Same drill like Gateway API. Add logging, add cost policy for React Next.js UI. It will consume this service. Add the controller and endpoints API Explorer to dependency injection container. Those were standard non-MCP related stuff. After adding Swagger stuff, we can put a code to read MCP info from mcp.info.js. This is a made up file by me. I am storing at this file first a URL to MCP server for the MCP client usage. URL is on our example http://localhost for 5207 SSA. Second, the API key for OpenAI can be created from their web portal to use ChatGPT as an agent here. Model ID can be, for example, GPT 4.1 or other ChatGPT models. According to the API key, we construct an OpenAI client. From this OpenAI client, we will use the model ID and create a chat client with factory pattern. We can now inject the DI container as a singleton instance. This instance will be used by controllers to query prompts to the OpenAI LLM models. To consume MCP server tools, we will construct a server-side event client transport with MCP server URL. With that transport, we construct an MCP client and inject it as a singleton object to the DI. Also, we implement a dictionary of GUID and chat session. Here we are storing the chat history with agent in memory. Chat session is a custom class that I have created, and I will come to that in upcoming slides. Let's implement some classes like MCP info, MCP method, and MCP parameter as records like this. Chat session is a class and memory template to store chat history and options. Same drill as gateway API. Implement an API controller base. Implement a chat controller as MCP client, and chat sessions components. Implement an HTTP get method that returns the MCP tool list. Get MCP tools async. Implement a HTTP method that returns MCP methods list. Get MCP methods. A HTTP get method for create session and returning the session ID. The chat session will be stored along with the MCP tools. HTTP get methods for retrieve sessions can be implemented like this. Let's create most important function of this chat control. Getting the prompt with chat/prompt/session ID as HTTP post method. First, add the user prompt. Second, get the entire response in one go, no loop. Third, get the streaming response from chat client. Collect any function calls we find. Collect any regular text content in current response text. And finally, collect usage details. Store the current assistant response even if we found functions calls. If we found functions calls, process them and return their responses only. Without other AI call, process each function call sequentially. Get the arguments from the function call, display the arguments, call the MCP tool, extract the text content from the result. Add only one final assistant response that includes both AI text and total results. Since chat message doesn't have a content property, use standard to string method. Return assistant message. Let's run MCP agent API at the port 5208. We can observe the node with MCP agent API Swagger output. It's ready to consume by the React UI. We dive into the React Next.js code base and create a chat page TypeScript file. First, import the dependencies, Next.js link, React use effect, use ref, use state. Define an API URL base for the agent API and the chat message class. This is the POCO representation of the Microsoft Extensions AI chat message, by the way. This was the response type of the prompt HTTP post of the API. We define the bindable properties that we are showing in the UI. Session ID, chat story, user prompt that user will edit on runtime to send to server, loading indicator, and input ref HTML input element to be able to manage focus after loading the page. I mean, basically focusing the prompt chat text box. Get a session ID on mount. Handle sending a prompt like this. When a reply is received, append both user and bot messages to the history. This way, we can render messages from the agent API. Finally, we render the HTML of the chat page. A home button, a title called Chat with MCP Agent, session ID underneath. Until it will show initializing session. It will render chat history and input box with send button to be able to send prompt to the server. Let's put a button to our new chat page. If we click it, we came here. In the end, let's make it a demo along with testing the whole system. Initial chat page will look like this. There is no conversation and it expects to type your prompt. A basic question like get me top 5 categories ordered by name gets a correct answer. It's very straightforward tool call and easy to respond by ChatGPT when MCP server tools are present. Let's check logs. What happening step by step when we ask this basic question, the first agent API. As the logs indicates, OpenAPI agent model ChatGPT-4 understands the prompt and the tools from MCP server. Finds out the necessary tool called get page categories. Execute and collect top 5 category by name in 6 seconds. We can observe the tool call also at the MCP server logs. Also, if we did dive and go to the REST Gateway API logs, the category service call is triggered with parameters skip 0, take 5, order by category, name ascending. A corresponding SQL command has been generated via Entity Framework, and SQL Server does the query and responded back to Gateway API. Let's check the actual data is correct or not. We went back to operational React user interface and check the categories. Yes, if we compare the results of the agent and traditional user interface, we see the agent is correct. Okay, but there are more beneficiary usage of this agentic web. Think about it. A new business requirement is coming up. A user of this application needs to sort out the categories according to product count, for example. Our user interface has lack of design and capability to fulfill this requirement. Times before agentic web, what we do was limited with development. Either we need to develop some reporting service and dynamic reporting pages for this type of requirements, or we improve the user interface with development processes. Today with agentic web, the reporting and user interface become obsolete because now through MCP Server and LLMs, we can talk with our existing application. Let's do it in action. Ask, could you please show me the top 5 categories with most products in an HTML table? That's it. You get the answer. The agent does every API calls necessary and collected that information in a HTML table and showing to you in a blink of an eye. Now your application is smarter. You can chat with your application and data. Try another one. Let's ask, what is the top ordered product and how many times it has been ordered? This is very time consuming. We are using this UI to find out. That answer is Charteris Verte with 750 cc per bottle, and it's ordered 311 times. Agents can do more if allowed. Our gateway API is not just read-only. It can do anything but React UI can do. Let's ask him, please create a random category and create 2 random products in that category. It's created a category called Gourmet Snacks and 2 products, Truffle Popcorn and Shiraraka Alamons inside that category. That's it. That's the end of our journey with MCP Server and client implementation over Northwind React application. The source code of this project is at the GitHub. You can follow the link. And please don't forget to subscribe. And if you actually like that video, don't forget to like this video. Thanks. See you next time.